Hello everyone, my name is Sanjeev. I am from Thapar University. I am in second year. My thesis topic is on analysis of big data by data deduplication technique. First of all, I will tell you about what is big data. Big data is high volume, high velocity and the high variety of information assessed that demand cost effective innovative forms of information processing for enhanced insight and the decision making. Having the data bigger, it requires the different techniques and the tools to analyze the data. There are different tools and techniques. First of all, we will discuss about the 7 V's of big data. There are mainly 3 V's, that is volume, velocity and variety. In volume, it tells about how much size of the data is big, and velocity tells that how fast the data is coming. Suppose today is an event, the data is coming very fast. And third is the variety. Data can be in any format: text, video, audio and any other format. So there is suppose there is we have to merge the data, then there is a query execution time will be very slow for the merged data. So there are the different issues for that: storage issues, privacy and the security issues, data access and sharing of information, and storage processing issues. Scalability issues. Scalability is the capability of a system and the network or the process to handle a growing amount of work, or its potential to be enlarged in order to accommodate the growth. Because data is increasing at a very fast rate, so there is a great challenge to store that data and access it in efficient way. Because different data has different format, so communication time between the different data format is large, so it increases the processing time. And second is the interoperability issues. Suppose the data is in the different format, so we have to communicate the data with one format to the other format. So it is the main issue for the big data analysis. In the interoperability issues, as shown in the different communications. And to analyze the big data, there are the different tools and the techniques as MapReduce framework, and after that I have introduced the Karma data integration tool, and another is the data deduplication technique. There are the three mainly two duplication technique. First is the data unit based, location based and the displacement based. In the data unit based, there is the byte level data deduplication, file level data deduplication and the chunk level data deduplication technique. Byte level data deduplication technique: suppose the data is sent over the network, then every bit of the data is to be checked, so that if the bit sequence is matched, then data is not to be placed on the network, otherwise it is placed to be on the network. In the file level data deduplication technique, every index of the file is to be maintained on the storage device, so that redundant data is not to be placed on the disk or the storage device. In the chunk level data deduplication, a chunk of the data is to be maintained in the hash table, and every hash value is matched over this. And chunk level data deduplication is of two types: static chunking and the variable size chunking. In the static chunking, the data is divided into the same size of the chunks. In the variable size chunking, data is divided into the variable size of the chunking. This is the data integration tool. Karma is the data integration tool. It is used for the clusters of the data from the different types of the data to convert in the one format of the data. This is my proposed method. It is the method for the record level data deduplication technique. Suppose in a record, data is in a different format. Suppose AB is a name and another format BA. These are the two different formats, but these are the redundant data, so we have to remove this. So record level linkage algorithm is applied to remove this type of redundancy. Suppose this is the sample data set 1, William J. Smith, W.J. These are the two different data sets, but they have the same but in the different formats. So this is the type of redundancy. We have to remove this type of the redundancy. For removing this type of the redundancy, we convert the data set P, data set L, and for each data set P and L we divide it in the subdata parts and match every name and the data and other columns of the data. Next is the time for the storage versus file size. As there are different techniques: chunk, byte level, file level, and proposed method. For the chunk level data duplication, time storage is great for the different data, but as the proposed method, it is low as compared to the other technique. This is the performance comparison. If we compare the performance of the chunk level, file level, byte level, and the proposed method, then the proposed method shows more performance. Here the axis shows the increased file size in the pages and the success factor in the y-axis. Conclusion and the query: different data duplication techniques can be applied at the record level to remove the format type of the data redundancy. In the future, we can apply the different filtering and the combination technique for the analysis of the big data. These are the different references I have used. Thank you everyone.